Okay, so graphing exponential functions. This is the part that you will be filling in the blanks on your guided notes. You do not have any of this filled in. So here is our basic equation. Yours is going to be even smaller, and we'll start talking about these transformations. But in a larger equation, in the exponent, this is where the horizontal translation will happen. So if you have anything added to the exponent, adding a number to the exponent will translate it left. Subtracting a number in the exponent will translate our entire graph to the right. If we have a number added behind the entire equation, then it's going to translate our whole equation up and down. And this is also where our asymptote is. And remember, we've talked about asymptotes when we did our rational equations. So we have experience with the asymptote. A is going to be multiplied by our growth factor, and A does something to our basic points. We're going to have these three basic points. It will multiply by those y values of our basic points, and it can either bring the points closer together, shorten the graph. It can also stretch it out. It can also, if negative, flip the entire graph over, so reflect it. So be sure that you get all of that filled in. You might need to pause. So here is for an exponential growth functions. Here is really what a very simple problem looks like. Just b to the x power. Nothing multiplied in front of b. That would be an a value. That would give a stretch. There is nothing happening to the exponent, which would shift it left, right, and there's no asymptote other than 0, our x-axis. So here's our three basic points. We will always go through 0, 1 unless we shift our asymptote up or down. And then our x values are going to be -1, or the 0, or the 1. And then here's the y values. So for the -1, the y value is 1 over, and b comes from your function. So it is that number that has the exponent on it. And then you have 0, 1. Then a third point will be +1 as an x value, and then whatever your b is from your equation. So whatever that number is, it has the exponent of x. So let's take a look at an equation. So here we go. If we have f of x is 2 to the x power, this is our b value. So we are going to have a 0, 1. So we're going to graph a point 0, 1. And since our b is 2, we're going to have another point at -1, and then 1 over b, which is 1 over 2. Okay. And then for the third point, we have 1 and b. So since b was 2, we have 1, 2 as the third point. So there's our 0, 1, which we always have. Then our -1, 1 over b, so 1/2. And now 1, and the b value, which is 2. So here's our three basic points. We don't have an asymptote out here, so our asymptote is going to be 0, which is going to be our x-axis. So we're going to approach 0. Oops, terrible at drawing. Go through our points, and then we're going to rapidly climb. So there's our exponential growth. We have an asymptote. Ta-da! All right. We will get to those problems together. All right, exponential decay. We still have three basic points. We will talk about what the b value is on decay and contrast it with a b value of growth. But you're still going to have these three basic points, always through 0, 1, and then your -1, 1 over b. But something is going to happen there because the b value is markedly different from a growth b value. And then we're going to have 1b. So the three basic points, the definition is the same. But if you will look at the graph, it is decaying. So it is approaching as it moves from left to right. It is approaching the asymptote instead of growing from the asymptote. as it is in growth. Okay, so I hope you have all of your notes completed and come ready with some questions, because I'm sure that you do out of this, but once it gets solidified in your mind, you'll be like, oh, these are the easiest graphs we've done. All right, see you Monday.